All right, let's dive in. Today, we're going to tackle a huge challenge in modern software. How do you actually build and manage all your cloud stuff without, completely losing your mind? We're going to break down a really solid blueprint for automating the whole thing using Terraform, Azure, and GitHub Actions. So, think about it for a sec. With all the incredible things you can spin up in the cloud, powerful servers, sprawling networks, apps that scale to millions, what do you think is the actual hardest part? Is it the complexity? The cost? Figuring out where to even start? Nope, it's actually none of those. The real soul-crushing part is the repetition. It's that manual, click here, type this, error-prone process of deploying and then updating day in and day out. It's a grind, it just doesn't scale, and that's the exact problem we're here to solve today. So here's our game plan. First, we'll really nail down why manual deployment is such a problem. Then we'll meet our automation toolkit. After that, we'll cover the super important step of connecting GitHub and Azure securely. We'll get into how we create our infrastructure blueprint with Terraform. And finally, we'll watch it all come together in an automated pipeline that plays out in 2 simple acts. Okay, section 1, the manual deployment problem. Now, the engineer behind the article we're looking at, Will Valeda, had one golden rule for his project: no running deployment commands from his laptop. Period. He knew from experience that doing things manually is a dead end. It just doesn't work long term. So he was determined to build a fully automated system from day one. His mission was pretty clear: spin up a Kubernetes cluster, get way better at Terraform, and, here's the big one, automate the entire process. And the key piece of advice from his journey, which is really our theme today, is that, this automation stuff is more work up front. But the payoff, it is absolutely massive in the long run. So to crush this problem, we need the right tools. And I want you to think of this less like a list of software and more like we're assembling a dream team for a mission. We've got 3 key players on our squad. First up, we have Azure. This is our canvas, our environment. Let's call it our world. It's the Microsoft Cloud Platform where all our stuff, like that Kubernetes cluster, is actually going to live and breathe. Next, there's Terraform. Okay, so if Azure is the world, Terraform is the master blueprint for everything in that world. It's an infrastructure as code tool, which is just a fancy way of saying we get to write down everything we want to build, every server, every network, in simple text files that we can actually read. And our final team member is GitHub Actions. This is our automated construction crew. It's the engine that does all the heavy lifting. It takes our Terraform blueprint, connects to our world in Azure, and just builds everything for us, automatically, every single time. All right, let's lock this analogy in, because if you get this, you get the whole process. Azure is the world. It's where we're going. Terraform is the blueprint. It's the plan. And GitHub Actions is the automated crew that reads the plan and builds the world. World, blueprint, crew. Remember those 3 and everything else is going to fall right into place. Okay, so before our construction crew can even lead the first brick, they need the keys to the construction site, right? This brings us to a super important and sometimes kind of tricky step: securely connecting GitHub Actions to Azure. We need to build a really solid, secure bridge of trust between them. And honestly, you can see the whole evolution of cloud security right here on this slide. The old way, it was basically a giant permanent key, a long-lived secret you had to copy and paste into GitHub. It was a huge security risk just waiting to happen. The new way is so much smarter. It uses a technology called OIDC, where instead of a permanent key, GitHub gets a temporary access pass for each and every job. It's safer, cleaner, and just way better. So what exactly is OIDC? The simplest way to think about it is like this. It's a standard language that lets GitHub say to Azure, "Hey, it's me. I'm running this specific job for this code. Can you please give me a temporary key so I can do my work?" Azure checks that it trusts GitHub and then issues a token that expires really quickly. No permanent secrets are ever flying around. Okay, our secure connection is built. Now it's time to actually draw up that blueprint. And a good blueprint isn't just a jumbled mess of instructions. It has to be organized, easy to read, and reusable. So let's look at how we structure our Terraform code to make that happen. If we're going to create a truly great blueprint, these are our essential tools. Think of modules like prefabricated Lego kits, a whole set of pieces that go together. Variables are the customizable parts of those kits, like picking the color or size. Outputs are the results we get back after we build a section, like its final dimensions, so we can connect the next piece properly. And data sources, they let our blueprint look at what's already built on the site in Azure before it starts. This is a really crucial point. How does Terraform even know what it's already built? The secret is the state file. It's basically Terraform's memory. It's a map connecting your code to the real resources sitting in Azure. And listen, this is so important. Because this file can contain sensitive data, you must never, ever commit it to your source code repository. Don't do it. Instead, we'll store it safely in a secure place like an Azure storage account. And the day-to-day workflow with Terraform is actually beautiful in its simplicity. It's always these 3 steps. First, init, which just gets everything ready. Then plan, which shows you exactly what's about to change. It's a preview of what's going to be added, changed, or even deleted. And finally, apply, which makes it all happen. That plan step is your ultimate safety net. It means our automated crew never, ever starts work without us knowing precisely what they're going to do. Okay, moment of truth. We have our world. We have our blueprint. We have our secure connection. It is time to put our automated crew to work. Let's see how all these pieces click together inside the GitHub Actions pipeline, which, like we said, is basically a 2-act play. So Act 1 of our little play is called the plan. And this act is all about verification and safety checks. It runs automatically every single time a developer suggests a change. The goal is simple. Before we approve anything, we want to know exactly what impact it's going to have. The moment someone opens a pull request, this job kicks into gear. It checks out the code, gets Terraform ready, and runs some basic quality checks. Then comes the magic part. It runs Terraform plan, and it posts the output of that plan as a comment directly on the pull request. So the whole team can see, right there, here's what's going to change before anyone hits the approve button. And once that plan looks good and the pull request gets a thumbs up, it is time for Act 2, the apply. This is the main event. This is where our automated crew finally picks up their tools and gets to work building stuff in Azure. Now, this job only runs after everything is approved and merged. It cleverly starts by downloading the exact plan file that was created and reviewed back in Act 1. And that's the key. It guarantees that what gets built is precisely what was approved. No last-minute surprises. It then runs Terraform apply, executes that plan, and just like that, our new infrastructure is live in Azure. And this all brings us to the final crucial takeaway, which the author, Will Valita, just says perfectly. He says, learning to deploy your infrastructure this way, through a CI/CD pipeline, is an investment. Yes, it's more effort upfront than just typing commands on your laptop, but the payoff in safety and consistency and in your ability to scale is, well, it's just totally worth it. And that's a wrap. We've just walked through a powerful, repeatable pattern for automating your cloud deployments. The process is clear, it's secure, and it's built to last. So the only question left is for you. Now that you've seen the blueprint, what's that one tedious manual task in your world that's just begging to be automated?